Let me try to catch up to you guys. So the claim, and again, I'm not always going to be this nice, underlining or bolding the key words. I think it's decreased from what it used to be. This number would never show up. This number would never show up in the first step because that's about the sample. And we don't do anything with the sample until the fourth step. Right on here. What? Oh, I love it. A, B, C, I love it. Makes sense. So which one is that? Where does that go? H1. What goes here? What goes in there for HO? Greater than or? No. Less than's already here. Yeah, greater than equal to. The HO always has to have an equal sign. We set it up that way so we can always focus on H1 to set up where the rejection region is. It's just how we chose to set this up. So it's going to be one or two tail test. Why is it one tail? Yeah, there's only one direction that I care about. It's not the beta. Alright, so it's going to be one tail down there. You got to find a sample way the shit down there to show evidence for the whole mean being less than ZT or nothing. YT, two things.
Samples 81.
Samples 81, greater than 30, check. And then what tells me T instead of Z?
Degrees of freedom. Degrees
Oh, I'm going to need degrees of freedom, but why? Why? What tells me T instead of Z? Good. The only standard deviation I know is S. Now be careful. Now real quick. I love the problems in the book. There's a little side note. There are problems in the book where they give you both. If I know, and of course I'm going to know both sometimes. If I know sigma, stay with me. If I just know sigma, they just tell me sigma's 2. Yay. If I take a sample, can't I find S? I can always find S if I take a sample. Would I use it if I knew sigma? Shit, no. Right? If I know sigma, I use it. Anything else is going to be a guesstimate for it, and if I know it, I don't need to guesstimate. So there are some problems in the homework where they give you both. Don't use S. Don't. If I know sigma, I'm going to use it. Right? Now, what's the difference between that and putting a list in your calculator doing one var stacks? It gives you both also, but what's that different? It gives you both because it doesn't know if the data you put in came from a sample or a population. And we're going to know because we put the shit in. So if it came from a sample, I know to ignore the sigma because I didn't put population data. You guys see that? I always get students who are like, well, this time you did this. And they're like, oh, come on, no. Think about the situation you're in. Right? Maybe. So here, I don't know sigma at all. I've got to use the estimate, which is why I need a score that covers my ass for using an estimate. That's the T-score's job. I like it. So for the rejection region, I know it's one tail. I know I use the T-score, so the degrees of freedom is 80. I know alpha is 0.01. So one tail, 0.01, that tells me which column to look at. One tail, 0.01. And then the degrees of freedom tells me where to stop. So I want to use 2.374. That's going to be my benchmark. Now what am I actually going to put down?
Negative.
Yeah, because it's on this side. Shade that tail in there. So how do I state this in words then? If my T star for my sample is less than negative 2.374, we can reject this dude, support the other dude. I just want to know, if you ever go to a coffee shop, you're like, I saw those old guys talking about something. There's always these old guys in the corner of newspapers or something like, what did you read about it? Oh my God. Very soon it's going to be me over there sipping my coffee. My God. All right, so what do we know from the sample? What was X bar? 880.34. It would have been funny if I would have like, all right, everybody, write your credit card down on the board. No, I'm not doing it. Let's just use this fake data. S was 106.25. What do I have to do with that immediately? Careful how you say it. I appreciate that. But that's why people think you're not supposed to do it. They're like, it's already a sample stand. No, no, no. What I'm doing is making it from an individual spread to a spread for 81 things. That's why it doesn't matter if it's sigma or S. I've got to change it if I took a sample and I'm talking about the means, which is exactly what we're doing here. So I've got to change this dude. Square root of, what was it, 81 again? 81. Whatever the hell that is. 11.806. 1.806? Okay, I like it. And now we can do what we have to officially call T star, which is the same old formula. It's the same formula because it represents the same thing. How many standard deviations away did our sample get? So our data minus the supposed middle divided by the new spread to see how far away we got. I don't know, 2.28. Negative. I don't know. How far on this thing? What is it?
Negative 2.173.
Negative 2.17? Okay, cool. So did we make it far enough away? That negative sign is going through. Did we make it? Did we find evidence? No. We didn't make it far enough away. Did we make it kind of far away?
Yeah.
Yeah. But it wasn't far away enough for this problem. Now, all right, let me finish this out, and then I want to give you a better feel for why the benchmark might be different sometimes. Can you imagine if I would have made alpha 0.05 or something, maybe I would have succeeded. But with alpha 0.01, I failed. So I failed to reject this coffee sipping view, and I failed to support his old friend that disagrees with me. Which language am I going to use? Which one was the claim? Which dude had the claim? What's the claim? So which dude? It was the high. So I want to use this language, not that one. I've got to reference the claim. Please let that make sense. My answer has to be about the claim that was made, because that's where we're investigating. So I just want my language to reflect what the claim was. So fail becomes we have not found sufficient evidence to support the claim that mean debt went down. There's one way to say it. So that sample of 81 students had less debt on average, but it wasn't less enough to show evidence that the whole population of students had less debt. So you guys are living that, I understand. Okay, so the last thing I want to do today is introduce what changes when I do a hypothesis test for a percentage. If I have a claim about the percentage of something that's going to do something, something's got to change. And what we're going to do is we're going to steal or borrow something from what we did earlier. How you doing, everybody? Yeah? Okay. Okay, so if I want to test a claim about a percentage, see if you guys can handle this. I never quite taught it this way, but I know the z-score formula, the z-star I'm going to calculate, has got to compare a sample percentage to the supposed percentage. So I'm going to say, I think that 32% of gross most students smoke. And I'm like, all right, let's test that out. So I take a percentage, I got a p-hat, and I want to see how far away that was from their claim. The same idea as this. I have a claim about a mean, I find a simple mean, and I see how relatively far away. What we're missing is, what do I divide by? What's the spread for this? And to be honest, we already know what the spread is. You're all like, you do? I don't know, Chuck. What was the formula for confidence interval for P? What goes right here? That's going to be the spread, right there. With one minor change, why? This is a really interesting question. Why are these wearing hats? What does that mean when it's wearing a hat? Sample percentage. So that is an estimate for whatever the population percentage is, the unhatted one. Right? Like it. Great band name, the unhatted ones. In a hypothesis test, I know P. It's going to be the percentage from the claim. So it'll be 32%. It'll be 0.32 from the example from a second ago. I know what it is. Or, for a hypothesis test, we pretend. We're like, all right, assuming you're right. That's why mu was 906 in that last problem. We assume that really is the real mean, and we try to show, oh, look, we just did something crazy. We didn't quite do something crazy enough in that last problem. Okay? I love you guys so much. So, we use this, but we don't have to use the estimates, because we're going to assume that we know what P is. So it's the same stupid spread. It's going to be this. So I want to always do my data minus the supposed middle divided by the spread. But for NPQ problems, we've already established that this is the spread. This is what we use for confidence intervals. We created this. Why do all that work again? Let's do an example, and then we'll call it a day. Here. This example kind of dates me a bit. Not that bad. It's not about 1950s protest. It's about Occupy Wall Street. Occupy Wall Street. Does that sound at all familiar? No, it doesn't sound like a great thing to do. Oh, I found it. All right, let's do this. It's the one, number one. Makes sense. Start there. The only step, there's two steps that slightly change. One of them is obviously when I calculate Z star. I'm going to use this. The other one is going to be how I make sure that I can do something. Step two, right? Let's see if you remember. So let's first read through this and see if you can write the claim down. Be very careful. This is a claim about a percentage. So I don't want to see little mu's or m's. You write an m for the mu. All right, let me see. So what's the claim? Say it in English for me. What's the claim? The percentage was at least 20%, right? So the percentage at least is what? Greater than or equal to. 20% is 0.2. I know nowadays students understand less and less, at least, at most. Just take a second and think about it. You have to be at least this tall to ride the ride. That's that or more, greater than or equal to. You have to be at most this old to eat off the kids' menu. That's that or less, right? Just think about it for a second. So where does that go? HO or H1? Does it have an equal sign in it? Yes. Where's the equal sign always go? HO. So H1 is going to be less than 0.2. So here's, I really want to, something that kind of trips people up, I think, is either you think about this directly or it's in the back of your head. I'm going to end up, so if that's us, we feel this. We are trying to find evidence for this. That's how science works. I think this, let me try to disprove it. I haven't disproven it yet, therefore that looks to be the best model so far. And that's what everybody misunderstands about science. You guys don't know shit. Yeah, we do. You don't think we're right? Disprove us. That's great. So in this case, I'm actually trying to show evidence against me. So in the background, I'm kind of hoping this fails. Do you see what I'm saying? Does that change my work at all? No. So don't let that kind of get in. It's just the way we set this process up. Sometimes we're actually hoping this fails. Look how nice that was here. Can we use Z-scores? Because you never use T-scores with NPQs. They weren't invented to work with NPQs. Can we use Z-scores? What do I check? So here's the other shift, the other change. Don't tell me N is greater than 30. That don't mean shit here. What do I check? I just did it a minute ago. I check something, something, at least 5. NP. And Q. Well, what's N? 996. And what's P? No work required. P is 0.2. Doesn't say anything about P hat there, right? I only use P hat if I don't know P. And we know P. P is 0.2. Bam. We're assuming that to be the real percentage. We're saying assuming that's true. So what is 996 times 0.2? That's at least 5. And then 996 times 0.8 is 796.8. No? Yes? Cool. Check. What's that mean again? That check I just did? What's that mean? That this is both greater than 5 what? What's that mean? Normal enough. So that's why we can use Z-scores? Yes. This is normal enough. I like it. So if it's not normal enough, you can't do shit. But again, anytime you run up against one of those, say something real quick, but then do the problem anyway. So maybe you're missing something. This step doesn't change. I want you to make this point. Anytime you're working with percentages, for confidence intervals, for hypothesis tests, you're never going to have to use T. You're never going to get degrees of freedom, any of that. It's always going to be Z or nothing. So I got 0.05. Oh, I forgot to ask. Is there a one or a two-tailed test? One tail, because I need my sample to show up way below this only. That's why it's a one tail. I need my sample to show way up down here. Way up down here, Jeff. Never claimed to be grammatically correct. All right. So 0.05, one tail test. What's the Z-score you get? Question. 0.05, one tail. So you use the T-score chart, right? Yes. What do you guys get? So now you look at one tail, 0.05, and I just make sure I don't stop. So then I get a Z-score, 1.645. Well, what am I going to put here? Negative 1.64. Why? Because it's below. It's down. I like it. So how do I say this in words? If z star is less than negative 1.645, we can reject this guy, support the other guy. You guys try part D on your own. I've kind of like stepped it out for you. So. You guys getting this for p hat? I'm really being nice because I don't ask for q hat at all because we don't need q hat. We don't need that shit. Because I'm going to use p and q. What was p? 0.2. So what's q? 0.8. There you go. So I got my data minus the supposed middle divided by square root 0.2 times 0.8 divided by, what was it, 996. Number 4. So what do you guys think? Stop the crowd. It's been a little while since we did this because, like I told you, I'm never going to ask you for a p-value for a t problem because the t-chart's not detailed enough to get that. But what the hell? How can somebody tell me the p-value for this? What's the p-value? So I really want this to make sense. Obviously. Alpha is the area and the tail of my rejection region. The p-value is the area and the tail that my z-score makes. Negative 1.26 is just like right here. What's this area? Below negative 126. It's a one-tailed test, so that's going to be the p-value. You don't have to double it. So now you have to use your z-score chart. What do you get? 0.1038? It's the only thing I've heard so far, so. Yes, no, yes, yes. Cool. So repeatability is good. So the p-value is 0.1038. I don't think I've done a good enough job of impressing upon you that the smaller the p-value is, the more evidence it is that something is different. That's why when you look at journal articles or something where they use statistical analysis, you always see them putting p less than 0.01. They're being all like, look what we did. Smaller p's mean less chance that it just happened at random, that it actually is evidence of something true, not just random happenings. This p-value is huge. 10%, that's huge. That's crazy. And that kind of jives with what's the result? Did we succeed or not? We failed. which remember is actually good news for us. Failed to reject the null. Failed to support the high. Why is that good news for us? Because which one were we? What was our claim? The ho, right? The null. And what did we do? We failed to reject it. It's like, oh, good. Yeah, we feel good about that. So we failed. We have not found sufficient evidence. 2, reject the claim that at least 20% opposed OWS, which sounds like a Harry Potter test. Just listen to the L. Okay, I think that's enough for today. The other side we'll do next time, and then we'll do the testing to see if anybody has ESP. So if you do have it, it's up to you to decide whether to show it or not.